Sorry, guys. So it was.
Welcome, everyone. It's a great day for the XX network, and we're super pleased to be joined by all kinds of members of the community for this. A little bit of a celebration, a little bit of an event, some interesting discussions, and so on. The keystone is that we are going to be allowing people in the community to use the XX network to send test messages and receive rewards for that to help us with the testing, and we're going to do that live here. So it's really exciting to see the messenger, this is actually working now with 340 live nodes and the whole community behind it. I just reminded of the origins of all this, which was like in 1979, I was sitting in a hot tub with my professor at that time at UC Berkeley, and we were looking up at the redwood trees in his backyard and talking about, well, what would we be able to do to demonstrate, what privacy, what would be a simple thing that we could use to really find a way to solve some of the world's privacy problems. And that's when I invented mixing. And I published it as a technical report in 1979. And it became my master's thesis at Berkeley, and it appeared in what was then the best journal of computer science, Communications of the ACM. And I mean, I'm told that there's several thousand references to it in technical papers. I don't know for sure because the estimates vary, but I can say that it's sort of engendered a whole kind of like conference series and direction of research, and there have been quite a few papers written in this field since then. And, unfortunately, no one has found a way to actually speed up the mixing since the original paper. Because, I mean, okay, when it appeared in '82, I believe the El Gamal signature scheme may not have been known, but it was plug and play because the paper just spec'd the properties, not the specific cryptosystem. So if you want to use messaging, metadata shredding messaging, and this is really the only technology that does it, with relatively low latency for like text messaging and chat and this sort of application, which has become hugely popular, then the known techniques do not allow for much mixing because of the computation that has to be done at each stage. So by a few years ago, I had the idea that maybe there was a way to move the computation into being done in advance so that when the messages arrive, they can be mixed and sent through with minimal computation at each stage. And this, there were a number of academics that joined me in that paper, and we had an implementation even, and some smartphone clients, but it really wasn't industrial strength at all. And so when we formed our company here to really take this to the world, we had to completely rewrite everything, and it's been quite an effort to make a version that is really solid and robust, extensible, and that also has a good interface for people to send messages or packets over the system. And I mean, it's not just for chat. This is any kind of packet of data. And so I'd like to say also that just to remind everyone, I'm assuming most people here know this, but there's really no other way to create the kind of anonymity sets and low latency that we're able to achieve. And, over the last 30, 40 years, there's been a lot of different schemes proposed, but nothing can do that. So, you can trade privacy for a lot of different things and uncertainty about privacy and so on. But this is, here I'll just mention another historic factoid, which oddly the community seems to have missed, the academic community, I should say, really. In the original mixing paper, what was described was a simple basic system, a cascade, which is similar to what we're using currently in the XX network. But there was another system also described that allowed messages to take arbitrary routing through the network that they would choose, but the number of hops a message had gone through would be hidden, even though, well, relative to the number of message size, and then for these return addresses to allow replies to come back to the original sender. So messages could take different routings through an elaborate network, and of course this would introduce different latencies depending on how much privacy you wanted, and create a lot of interesting options. And so whenever there was more latency, there'd be more privacy. So it's clearly superior to, but when you want to move to a low latency which is what our design goal, and I think you'll start to see other apps that are going to be really able to take advantage of this and really need it, then you have to kind of move back to the basic mixing with a single cascade batch to really get those large anonymity sets accomplished quickly. So that's a little background on mixing. Now I'd like to mention, of course, that how great the team is that's been working on this. And these are people, some of them I've been working with for like a decade, or more than half a decade. And also I'd like to emphasize that those are the people that really put the effort into design, architecting, and pushing this all forward. But they've brought together a really great team that's just chugging away, killing it on all these sprints that have really created a super system. I'd also want to point out that there's also the UI part of the front end part, which is a whole other effort involving a rather sizable team, which you may know. And additionally, all the other technical people in the company have been collaborating with this, that are working on other things, have been collaborating to help move this all forward. And there is shared code and shared infrastructure, and so all of that's been greatly beneficial, and I think it'll also have benefits to other portions of the system as they come out. So this is been a great group effort. And if you drew a heat map, you might see a few key people at the core of it, but it does extend out to the whole company. And so everyone is to be congratulated for their collaboration and participation in this. So without further ado, I think I would like to turn it over to, I once introduced Ben as our beloved Ben Winger in the project, who will tell you a little bit about the game now, I believe.
Thank you, David. That was wonderful. A lot of us kind of came into this in the last few years, so the history is very humbling, and the chance to work on something that you've worked on for so long is really, really profound. So the other thing that's profound is, in fact, even though we've not gone into and explained the game yet, we've had many people who've played. So I'm going to start by reading some messages that have come over the network already, some of the first public messages over the XX network. Then we'll go in and I'll just give a little tutorial for those of you who have not yet figured out how to use it. The first one just came through, said, Salam XX. Then Lituanica is in the air. And someone else wrote, mistyping XX with XXX can surely lead to a very unexpected experience. Someone else just said test. Then we have wow, something real to play with, like a one-armed XX bandit. Someone else went a little more classical. Hello world, my first XX message. And someone gave us a little more personal information. Hi, XX network people. I am BetaNet validator named Ramucci, smiley face. And then we got, hi, this is you from the past. Another person said, hi, XX team. Just wanted to send love and support from the Millennium Club team. Over 8 MCLB members are currently helping support XX Network by running nodes globally. Proud to be a part of this wonderful family. See, ciao, XX Network. It's a great day for the XX Network. Run, run, run. Less trust, more truth. And XX Network rocks. May this be one of billions of real messages processed. Neutrino. So we'll read more of these as the hours go on. And it's pretty incredible to see the public using this. Of course, we've done tests internally over and over again, but this is a whole different thing. So I'm going to present my screen, and I will do this myself. Basically, there is a link in the description here to the forum, which will let you download the game. There are different versions for different operating systems. We've got Windows, Linux, and Mac. Mac is a little bit more complex, fortunately. You've got to do a little bit of command line foo, but it's not too bad. I want to start off by reminding people that, unfortunately, in order to make sure we comply with different laws, only those who already have XX coins can win coins, although anyone can download and send messages in, and we'll read them. Once you download it, you extract it, and I'm here on Windows, so I'll just run xxcoingame.bat. And the first thing it does is it connects to the network. The first time a client connects, it connects and then it registers, and it takes a little bit of time. I'd already done that, so it's fast, but you'll see a bar, and you will communicate with just about all of the nodes in the network to make sure that you've got keys to send with. And then you put an Ethereum address. I'm, of course, going to put in a dummy. Let me grab that. And then you simply send a message. So this is going back and forth. The network is not as fast as it will eventually be. We're still working on it, and there still are a few bugs, so sometimes messages drop. I think within the next week or two, we'll finally squash the last few of those that exist. And so sometimes we'll get an error. Hopefully we won't this time, and if you do, just send again. It's written to assume that sometimes people send multiple times, and everything will work. Another cool thing that we have, as you see, it worked. Hello world, and I got 32 coins. The amount of coins you get is random. It's anywhere from 32 to actually 1,024, and each step up is a power of 2, and half is likely. So hopefully we'll see some larger winners. If your message times out with an error, just click send over XX a second time, and it should work eventually. And the point here is for us to get those errors, capture them so we can fix them. So if you get errors, we'd really appreciate if you would email us the log so we can see what happened and we can fix it so that the errors stop. And so this is really helping us test the network. Yes, so here is what it looks like. You're going to have a little script here to start the game, and then you've got assets. Inside assets, you've got a file here called xxcoingame.log. I'll open it in case people are curious. This is actually coming, one sec. This is coming from inside the client, and it describes all the work the client does, so it's a detailed log. And from this, when things go wrong, we can see exactly which endpoint it hit and what happened. So this information will really help us fix the last remaining bugs. So that's pretty much it. It's a quick, easy game, but we really hope that you enjoy building this network and starting to use it with us. We're now going to go into a few different segments. After I think maybe some of the members of the team say some things, the first one we're going to talk with some node operators about what we can build with the XX and everything we can do. The second one, we're going to talk with some other node operators who've really dug into the source code of the network. We're going to talk a little bit about how this client that's underpinning this game and the messenger and the xxDK really works and how it's built. And then the last thing we're going to go into is we're going to talk with Kate and a few other node operators of the XX messenger, kind of what we're thinking about and how we're approaching the problems and solutions. So with that, does anyone else on the team want to say anything before we move on to our first topic?
I could read some more messages.
Why don't you do that? This is Sydney. She's our resident system admin. She was up with us late last night or this morning to make sure everything was working. So, yeah.
All right. We have hello XX Network. Keep up what you are doing. Cheers, Craft Rock Network. We have hello world. We have a question. When will you go public? I don't know if you can answer that one.
I think we'll have more information on that soon.
My first test message. Hope it will arrive. We have, and from these messages, a new future begins. Hi, I am sending this message from Brazil. We have very exciting. We have hello everyone. We have, oh, I'm going to probably pronounce this terribly, but we have Lu Shu Films VR, and we have another hello world. These are messages that we've had sent in so far, since Ben had read the previous ones out.
So I think that those of us who are in segment 1 should stay here. And we're going to bring in some node operators, and I think we'll have an interesting discussion. Yeah, I think let's wait a minute for the node operators to trickle in. So the first conversation is going to be about possibilities with the XX network. It's a big conversation. So we've got members of the Elixir team, myself, Jake Taylor, Rick Harback, Sydney, and Jonah. And then we've got members of the Praxis team. So Will, Mario, Balthazar, and we're going to be discussing. So we kind of cover the full framework of things that you can do with the network, and so right now the xxDK is out. It allows access to the privacy features. The blockchain will be coming shortly, and here's Devesh Gupta. Hello. So you're one of our node operators, right? Okay, so so we're going to be talking about what we can build with the XX network, what we can do with it, and it has what we've built right now and what's immediately coming, what's coming in the long term is going to support a lot, and our focus is really on decentralization, trustless systems, and privacy. And this is something that I think that I can speak for most of the team to say we think that the world really needs. Democracy societies around the world are faced with issues that deal with privacy, that deal with trust, and the ability to have a system which doesn't impede on those issues, we think can really enable new growth and freedoms. So what I'd love is for the node operators to drive the discussion. You're really here to represent the community and bring in a voice from outside the team, which is what is heard mostly. So if any of you have any questions, that'd be a great way to start.
Hey, can you hear me?
Yes. Hi,
Yeah.
Robert.
Hi. I really liked the app. It was nice to play with it. When will the payload capacity of 501 be like unlimited, like raising the cap of the message length, so to speak?
So right now the the client is built so that these fixed size payloads, the actual payloads are 8,192 bits, but it already has the built-in capacity. So if you send it a message bigger, it will automatically chunk it up into smaller payloads and send them to the other side. And the other side will automatically reconstruct them before handing them over to the other side. We don't have special code written to allow for very large payloads, so that sends it over a longer period of time, but that is coming. But right now already we have not insignificant. We already allow for larger payloads. That size was just limited because we wanted the ability to read them out loud, and it was a little hard if people start sending books.
That's great. So, hi, I'm Devesh from India. So, yeah, I read the message. You read the message from Millennium Club. I'm here representing the club. So we have lots of excited node operators, and a few more are probably trying to join soon. So they wanted to know one thing: in future, when the staking requirements are started, will we have a minimum amount of XX they'll need to buy to set up a node, or will it be open, like they can stake with one single coin and the rest can all be delegations?
We're still working out those details. I think that we're leaning towards a system where there's a minimum, but the idea isn't for it to be punishing. I don't think we're looking at a system where someone needs to own 100,000 worth of XX to stake a node, and that's one of the advantages of the NPOS designs that we're looking at. So we'll have more on that soon. But if there is a minimum, I don't think it will be particularly difficult to hit.
Great, that's great to know. And in future, are we expecting any significant change in the hardware requirements?
So we've spec'd the nodes to last for a while. I'm not expecting it to change, at least not for the first years of mainnet, with the single exception of bandwidth. At some point, it is possible that bandwidth will need to increase. It is actually the big bottleneck in the network right now. It's really hard to tell exactly what's going to happen with that. It's heavily dependent upon how the economics evolve and a few other things, but that is the one possibility that we potentially see on the horizon.
Awesome. So I've also heard that there is some big product or big industry use for XX coming. So I understand you might not be able to divulge any big names yet, but any idea which industry, which field or use case our first big customer is going to be?
I actually don't. I personally can't say much. Will might be able to say more. But talking from a more theoretical sense, there are a lot of industries where privacy is important. There's medical, financial. So I think it's really important for those industries where privacy is important, confidentiality is important, and security is important, those are the places where we really think we'll see adoption. I don't know that we can say much more than that. Maybe Will can give more insight.
Sorry, I was typing to the community in the YouTube channel. Can you repeat the question?
Sure. I was wondering if, I mean, I'm sure that the team can't divulge info about coming partnerships and use cases, but maybe not names, just the industry or the intended use in that industry, so that we get an idea where the initial base and build up of XX network is going to be?
Yeah, so yeah, we aren't at the point where we can give away names, as you guessed. The industries that we've seen some interest coming from, actually, one of them is enterprise blockchains. So one of the potential partnerships where our partners we're working with has it's a kind of household name in the enterprise blockchain space. They're working with big companies like IBM, Google, and stuff. This is not a final partnership by any means, but what they're interested in is they have like a full stack solution, and one of those stacks is like private transactions and smart contracts. And what they don't have is a communications network by which people can interact with their stuff. So one of the things that they said was we could probably saturate your messaging throughput on day one, which would obviously be pretty exciting for the project. But yeah, they're focusing on enterprise applications, and I don't have details on the industries they're focusing on. I would say like some of the applications we're incubating internally were kind of framed around this this thought, which is what can you do with private communications? So, you know, one of them is obviously the messenger. It's a pretty straightforward, obvious use case. Private communications in general. Another one is, and we've talked about this in other webinars, but it's a project that's being built on the XX network to use decentralization and the power of kind of social thinking to detect and adjudicate fake news in the media. So this would, like, you know, it would build a currency on top of the XX network, and it would incentivize people to go out there, hunt down and detect fake news, report it to the platform. The platform would use some of our quantum secure randomness to form random juries, and those juries would then be able to, you know, ask the community for evidence one way or the other, whether or not you know, news is fake or not. And part of that private messaging fits into the submission of evidence, the formation of juries. So being sure that you can kind of make an informed decision without the fear of kind of repercussion based on your decision. So these are all areas where privacy becomes really useful. And then obviously in voting, and that leads to another DApp that we've internally, I guess you could call it a DApp that we've internally incubated and worked with voting experts and academics from around the world. And we have Mario on the call. He's actually, along with David, and I don't know if Rick's on this meeting as well, but they're all kind of intimately involved in this project, which is kind of an interface by which people can set up and deploy elections anywhere in the world that are completely end-to-end verifiable by the voters themselves. They're also completely secure, they're completely private, and they're vote buying resistant. Mario, do you have anything that you want to add to that?
No, that's pretty much a good summary. It's very exciting tech, and we're already releasing kind of like some white papers in the wild. We're trying to come up with the actual formal publication where we do all the formal proofs. But this is it's a very significant issue that we're able to solve electronic voting and addressing vote buy-in. It's a very, very good solution, very modular as well. So I would expect a lot of updates on that. We'll be releasing a lot of documentation. And you can find already some summaries in the link that Rick just shared in the chat.
Can I interrupt here to read out some more messages?
Of course.
Yeah.
Okay. We have hi from Quebec, Canada. We have Weirall Satoshi. We have hello there. May XX Network grow and proceed smoothly to mainnet. We have greetings from the Netherlands from one of the XX Network beta node operators. We have wish you all the best with XX Network, guys. We have the revolution is here. We have hello world, this is Portugal calling. We have first message. We have thanks all the team for their hard work. Love you and good luck. We have hi. We have hello world. We have hi XX team, this is great. We have greetings from the future here. XX Network is already the greatest network on the planet. We have Ubik here. We have hello from Russia. We have this is my private message. We have hello friends. We have let's see what we can do here. We have hello from London. Good work, guys. We have a big hello for the new change. We have nice. We have hello XX team. We have test and we have hello XX. These are the messages that we've been sent since the last time that I've read out messages.
That's quite a lot. For node operators who are here, do you have any other questions?
I don't need to hog all the questions, but just one more.
Sure.
So, I mean, we are getting industrial use, as you guys mentioned, and we'll have enterprise blockchain was the first mention. So are these industries who are incorporating XX expected to run their own nodes? Would they want to? Would they need to?
Our design doesn't require the running of a node to use the network. It's part of our approach. Obviously, if you need blockchain data, you may want to run a light node so that you have that up to date. But in general, no. So the dapp that you all use today, it's a very simple one. We built it in one day. Is just the client. It doesn't require any of the other code. And this is designed to make it as simple as possible to develop and use, and to make it flexible to many different use cases. So, it's a long way of saying no. It's not necessary to have a node to make a dapp or use the network.
Would it be more of an incentive for the network if it is a requirement? Maybe they lock up a minimum amount at stake to be able to use XX network, or just an idea, I mean.
That is not one we've considered. It's actually an interesting one. I'm not sure that it fits with the rest of our plans, but it's certainly something we'll discuss.
Well, the staking aspect of it is in line with kind of our postage approach. So yeah, if an enterprise blockchain or just an enterprise in general wanted to send a lot of throughput through the system, they could run a node, but running a node doesn't inherently give you access to more transaction throughput, just like in any other blockchain. So what you would instead do as an enterprise is stake those tokens for, say, postage, which and the more tokens you stake in general, the more throughput you would get. So in that way, it would help the network because they would be locking up a large portion of tokens to get resources to use the network.
Hello, Ben and community. Can you hear okay?
Yes.
You're a little soft, but yes.
Great. One question with regards to time frame and what should be happening, I don't know, in the next 12 months maybe, in terms of movement from betanet to mainnet. I know you cannot say it for sure, but your expectations in terms of when should we be seeing the first use cases in the type of cases that you have mentioned. So if you could give an idea of what should be happening in the next 12 months or so.
I think there's two parts to this question. The first is about use cases. As many have experienced, the communication, while it's got a few bugs left, is really coming close to the point where it's ready for use. And even in BetaNet, we hope to start driving usage with the messenger and hopefully with other partnerships. As to the question of the timeline for mainnet, we're not going to give an explicit timeline because these things are always dependent upon things you can't control. But as David said in his letter, which was released, I think, last week, we're focused on getting mainnet and trading and global trading, as soon as possible. And I think that's going to be a relatively short time frame. I don't know if anyone else on the team has anything else they can add to that.
No, and I think in the letter we pointed out in the AMA, we pointed out that we're trying to basically get to mainnet and, as Ben said, trading by summer. The following months after that, so the rest of the year, is likely going to look like continued feature development. There's a lot of advanced features of the network that the group would like to continue working on. Of course, we'll be in mainnet at that point, so a lot of that development will be driven by the community and which features they want to see us develop first. Notwithstanding some type of security critical features. So that's kind of what the next 6 months after we reach mainnet, 6 to 8 months after we reach mainnet will look like. It'll be obviously shoring up the security of the network, patching bugs if they come up, and then working on some of these more advanced features, which, I don't think we're ready to kind of talk about in detail yet, but hopefully soon.
That's great. So are we seeing any reason or any way by which we are incentivizing new developers to build on XX? Is there going to be an incentivization or developers program of some sort, maybe?
Yeah, definitely. There's probably going to be 2 general methods. So if you have an idea for the XX network and you want to build something, there's generally going to be, I think, and you don't hold me to this, but we're considering 2 approaches. Both will be available. One would be coming to the foundation. So the foundation will have an allocation of tokens, and one use of those coins is to basically incentivize, as you say, developers to build interesting apps. That would be kind of at the foundation's discretion. And then alternatively, part of our governance plan, which hasn't been described in a lot of detail just yet, and hopefully we have the final proposal coming out soon. But part of it has a treasury built into it, from which a portion of each block reward goes into it. And the thought would be that you could actually petition the community directly for access to some of the funds in that treasury. And if the community thinks that your project's good, then they can approve some of those funds to help with your project. And again, like the logistics of exactly how that would play out will be left for that document that's coming out soon. But yeah, so there's going to be roughly two approaches to come to the XX network for help developing. It'll be either to the foundation, or you can kind of petition the community directly.
Another question with regards to the hardware potentially evolving in the future. Ben commented that one thing that could require an improvement is bandwidth. And with regards to that, in particular, some geographies. For instance, Latin America, from where I come from, it has been a challenge to reach a certain bandwidth so that we have error rates reasonable enough. If that happens, that the network requires a bigger bandwidth, is there a plan or an idea for something like geographic clustering or something to have shorter communications if there is a critical mass of nodes in a certain region, for instance?
Yes, I mean, I wouldn't call for it as a plan. We have a series of brainstorms and ideas and ways that we want to handle it. We're not certain in the direction that we'll go. There are, this network is very different architecturally than, most blockchains. So there's questions of how do you incentivize it and how do you combine these things, which are new challenges. And we're looking, as we're going to specify the governance, at building mechanisms to better specify. So if there's locations where the network wants nodes, potentially finding ways to make that affordable for the node operators. Or if there's nodes who don't meet spec, finding ways to allow sets of nodes, say, to band together and to group so that they can operate together. This is kind of like the ever-present pull. The reason you want more bandwidth is because you want each node to be doing sufficient work to make it worthwhile to the network to pay them. But part of the value of nodes isn't just the work they do, but it's the place they do the work from. You want this thing to be spread out because you want it to be across as many different jurisdictions as possible. You want it routed as far as possible to make it as hard as to make the privacy as robust as possible. And as we move towards the more final ones, weighing these is going to be hard. And I think one of the hopes that I have is that as we hit mainnet and we go through this transformation period, which could take 6 months, a year, that the community will be part of answering these questions. The harder the question, the more important it is that it's not just the team answering it. So my answer to you is it's specific no, because I think it is such a hard question that it would almost be inappropriate for the team to decide that a priori.
Can I just point out something super quickly? And this is, I'm more than happy to discuss this on Discord if you want. Like, one of the research tracks we have is actually how to improve the liveness of the mixed network. And so we're actually submitting a poster this Friday for a major conference. And ironically, or kind of by accident, one of the side effects that this construction that we're working on has is if multiple nodes fail with nodes that are kind of far away, then the selection algorithm ends up incentivizing nodes that are kind of closer and they have like good connection with. So like reliable pairs get prioritized. So like I'm more than happy to share this with you, like even before I submit it for you to kind of see like where we could leave it. This is just some internal research we have. It's not planned to be deployed in the near future, but we're working on that.
Would you like me to interrupt to read more messages?
Sure.
Okay. We have ping pong. That's NFT this message. We have the happiness of your life depends on the quality of your thoughts. Therefore, guard accordingly and take care to entertain no notions unsustainable to virtue and reasonable nature. Marcius Aurelius. It's a quote. We have hello world from SGP. We have first message hi from Toronto. We have test. We have hi from Ukraine. We have another test. Greetings from Turkey. I congratulate the whole team wholeheartedly. An excellent job you have done. I wish it will be completed in very short time. We have BLX Pro node is here. We have how much wood could a woodchuck check if a woodchuck could check wood? We have hi, I'm waiting for my certificates to start running a node. We have cool. We have hi. We have 1024. We have finally got it to work. Reboots work wonders. They really do. Computers are fickle things. We have hi, this is Schrodinger. We have the XX network the best. We have XX network is the way. We have the future is here with XX network. We have a message in Russian, and I have no idea how to pronounce that. Do we have anybody who could read that? No?
No.
Okay.
So I think that's just about it for this segment. We need, so the next one, we're going to be talking about the internals of the xxDK. We have some node operators and community members who've actually really dug into it, and they found some bugs, they fixed some errors. It's actually very cool to see members of the community really participating. Those of us from the team who are part of the Elixir side, why don't we stay here to answer questions about the xxDK and how it works, and be a little more of a technical conversation than we've had up until now. And we thank the node operators who joined us. We hoped you got your questions answered, and that we really did enjoy you coming here.
And thanks for your support.
And of course,
thanks a lot for having us, guys. It was a pleasure being here.
It's great meeting you, Devesh.
It was great to have
Thanks a lot. Bye-bye.
So we have Alex here with us. I believe Neutrino is supposed to join shortly. Tell people a little bit about Alex. He's probably one of the, if not the most active member of our community. He's found multiple bugs in the network. He provides daily network set updates that are more detailed than what the team provides. I think more than once you've been mistaken for a member of the team, and I mean, obviously we're both scared and excited every time you send us something. Yeah, Neutrino should be here shortly. It seems like technical difficulties. Let's give it a second. And there we go. And then we have Neutrino, who has been, along with Alex, testing the messenger. They've been kind of prodding us on how to get it working, which we've not been exactly as forthcoming on as we probably should have been. And yeah, that's basically what
Hello.
Hello.
Hi, guys.
Hey, Alex. So we're hoping that you guys could drive questions, ask us maybe a few things that you're curious about, and go from there. We've had some really good discussions recently. Neutrino, you gave us some information that showed that the bandwidth usage of the client is not where we want it to be, which has led us to start a project to reduce it. Yeah. So, what questions do you have for us?
Okay, I was wondering if you can support group messaging. If XX Messenger will support group messaging, and if this is something that you deal with on the front end on the XX Messenger, or is it something that the client, the xxDK, supports it?
Yes, this has actually been a long conversation for us. Group messaging is hard because it's just a cryptographically more complex operation. We have multiple plans for group messaging, and I think that we'll actually probably get the more simpler version of it out in the next few months with more complex approaches, which allow for channels of hundreds of thousands of participants a little bit after that. Mario is actually a good person to talk about this, but basically the problem with messaging is that the way that the end-to-end encryption is built, it's built with symmetric keys. So two parties do a key negotiation, they get this core key that they use to generate new ones off of. That becomes, exponentially difficult the more users you add. If you've got 5 users in a chat, each person has to do a negotiation with others. Okay, that's not too bad. If you have 5,000 users in the chat, that becomes a little bit worrisome. So, you've got to make trade-offs between size, speed, and it's certainly an interesting conversation, which is constantly had. I saw some conversation on Twitter between some known cryptographers recently. There's never a single good solution. So generally, when you really solve, you've got a patchwork. I know, Mario, if you've got anything you want to add to that.
Yeah, sure. So kind of like the problem in a nutshell is how do you actually deal with the encryption, right? Are you actually going to send one message for each user in the group chat, and then that's kind of like mayhem, or are you just going to send one message with then authentication tags with a key for each of those people, so you kind of grow linearly only in the authentication of the message? Or are you actually just going to sign the message and it's just one message for everyone in the group, and kind of the infrastructure deals with that? And each of those solutions kind of has its own problems, because if you sign, then you cannot deny that you sent it. The other one, you send one per user, if the message drops, then Ben doesn't really read my message, but everyone else reads it. So it's very tricky. We are following very closely the MLS standard. So there's an IETF going on right now where they're actually trying to like formalize an RFC for group chat. So like if we can incorporate that with us, because it's kind of like designed to have interoperability between chat apps, that's the ultimate end goal. Like the more we can be compliant and interoperable with other platforms, it's the better thing to do. But right now, we're like Ben said, we're just trying to deploy something that works, that is private, that you can use, but it's not the final solution. But it's already like super good and way better than a lot of like other commercially deployed apps. Trust me on that.
One advantage that XX Network gives is that under the hood, the CMX Elixir protocol is actually a broadcast protocol. It's not a point-to-point protocol. And what this means is that when you send a message, you're sending to an address. In fact, we've got another layer on top of that where you're sending to these dense, ephemeral, colliding addresses. It's a little bit opaque, but as a result of this means that actually any client can go and pick up any message for any user. The thing about it is that they can't decrypt it. What this means is that you can build protocols where a group chat is actually a user on the network that everyone sends to, and if you know the identity, you can receive there, and then you need to have keying material between everyone to intercrypt from that user. So options like that allow for us to build this really efficient group chat, because the system is actually a mixing system and then a delivery system. And I think that those solutions are a little bit farther off, but it allows you to have a system where messages are only mixed once and then delivered to everyone in the chat. So I'm pretty excited about that possibility, even though it's a little bit way off.
Okay, thank you.
Hi. From my point of view, I think it would be interesting to have a high-level overview and not so high-level on how the client works. So how it sends messages, how it retrieves the messages from the different gateways, how are the ephemeral IDs generated and used, and so on.
Sure, that's a lot, but
yeah, I know.
some of it. Is there any of those specific questions you'd like us to answer first?
No, not really.
Okay, I'll start with.
I'm asking because, as you may know or have guessed, I've started to implement a client in Scala.
Mm-hmm.
I'm not sure if I'll ever finish because I'm doing it just for fun during my free time, that is almost zero. But obviously, the thing is to read the source code and try to understand the high-level picture. And other thing is to know the high-level picture and see it in the code.
Mm-hmm. We definitely need to have more design documents on how it works. We've got some internal ones that we haven't released because they're not, I guess, pretty enough yet. I guess the first question that you asked, and probably the first that I'd like to answer, is, what's basic architecture? And there are multiple ways that you can pick up data from a blockchain. One thing that I think Alex has noticed is that often when we're doing things, we're focused as much on speeding up the development as we are on the best solution. So the solution we have right now is something that we call network following, where a client sits there and is pulling different gateways and reading the state of upcoming operations in the network. This can be done, so instead of constantly pulling, you're only pulling when you need it. But as you do that, the client gets more complicated. So we've started with this approach first. And basically what it does is it pings a gateway, sucks down the list of upcoming operations, and then it stores them in various data structures to allow for easy access for different parts of the network. And sending is pretty easy. When you call send, it chooses an upcoming round, encrypts the message for the round, sends it to the gateway of the first node, and then it includes it in the round. Receiving is a little bit more difficult. Receiving is done through a gossip protocol. And so what happens is that when a batch finishes, it gets sent to the gateway for the last node of the team, which shares the messages with the other gateways for the nodes in the team, and it gossips a list of the ephemeral IDs of the recipients to the whole network. And every single gateway on the network is building what are called Bloom filters, which are these probabilistic data structures, which and basically it has a Bloom filter per ephemeral ID constantly. And so as a recipient, I can go to anyone in the network and I can say, hi, give me all Bloom filters in this time period for this ephemeral ID, and it'll send them to you. They're not very big. Each one is like 50 bytes. And it will then use that to check to see if that ID has received any messages recently. And you check the Bloom filter. I'm not going to explain the mechanics of them. They're a little bit opaque. But basically it gets a positive hit and says, okay, round 82 billion. It's a lot higher than we're at, but 82 million. I've got a message, and then it will either check its internal data structures to see, do I know about this round, so I can know where to pick up the messages. If it does know about the round, it'll just go get it. If it doesn't, it can query any gateway to figure out about that round. And then it will just go to the gateway and request the messages, say, give me all messages for ephemeral ID, 85 in round 82 million. And that's the short version of it.
Okay, thank you.
As to you asked about how the ephemeral IDs work. That's really need to publish what we've written internally on that. Basically, every client has an ID, and on every 24 hours at a random time, they swap to the next ID. And you've got a basic ID, and basically you hash that with the time period. truncate it to the current address space size, and that's your ID. And the idea here is actually that people's IDs will collide. So I'm going to have the same ID as a few other people at a time. I'll end up downloading their messages, but I can't read them. And that obfuscates to an attacker who's who. So it fixes some problems known as tagging attacks in the network, and it also makes it so that the network just knows less about what's going on. It adds an extra layer of privacy. So that was a quick rundown. If Alex, you have anything specific that you wanted?
Yeah, it's been useful. No, it's fine.
Okay.
My other request is to try to avoid, as far as possible, in the client the use of Go-specific things. I've seen a few of them that make it harder to create another implementation in a different language. For instance, I've seen that the user data is stored into the encrypted storage with the Go binary encoding that uses the Go reflection. So it's quite hard to create an encoder decoder in a different language that is able to use the same session created by the client in Go. Mm-hmm. Or another thing was the time encoding into the message that again it uses the internal Go binary Marshall error. And another thing that probably I already said a few months ago is the hash over the network definition file that is done over the JSON encoding in Go, that in other languages again can be different. And that's all.
I did not realize that we were Go specific on the NDF. We'll look into that faster. I think that's a higher priority issue. The network ones I think will fix pretty quickly. The ones in the EKV and the client, we definitely will. I think that you're absolutely right. We shouldn't use Go specific implementations. That may take us some time to get to just because everything we're working on. But yeah, we'll work on migrating those things. I think that you're absolutely right.
Okay, good. Thank you.
I have a couple of questions.
Sure.
First, for me, looking and developing on xxDK is an opportunity to learn Golang. So for my first, let's say, project, I would like to develop some Python bindings for xxDK. Mm-hmm. And how easy is it to do it? To develop bindings? Do I have to first develop a sort of wrapper around the client API and then export functions using CGO to Python? What's the best approach?
That's an interesting question. I'm actually not sure. Maybe someone else on my team has a better answer. We've done it already for Java and Swift, as is in the bindings package there, but that's using an already extant system called Go Mobile, which we write interfaces in Go that adhere to a specific spec, and it automatically translates it over. I know CGO isn't particularly difficult to use, but I would have to do some research to know the right way to do it. I don't know if someone on my team, maybe Jake or if Rick, if he's here, might have a better idea of, or give you better advice than I could.
Secondly, what's the purpose of the 8-second idle time between pre-computation and real time? It used to be about 800 milliseconds. Does it have to do with messages on the gateway or something?
So that's actually intended to give time for clients to sort of get involved as rounds progress through the network. The shorter that time interval, sort of the less opportunity client has, as we were just describing earlier, to sort of look ahead and decide where it's going to send its messages. And so by giving that extra time, gives clients, especially like a number of clients, more of a chance to this message in each round. Of course, at the expense of sort of slowing down the overall progression of things, but sort of moving into the immediate next stages, that's definitely where the importance lays.
Okay, can it be done asynchronously? Like client sends to gateway the message, and the gateway finds the appropriate round via communicating with a node which round to send the message, and then tells the client, okay, I sent this message on this round. So
you can
like implement a queue-like system or something.
So the problem is that a message has to be encrypted for a specific round, so you can't send it in a different one. It'll come out incorrectly. Now, the 8-second advertising time, I think, is longer than it will be in the long term. I think we can get it down to 4 to 2 seconds in that range. We started off making it large as we're trying to get it working, because you optimize one thing at a time, and we've not gotten to figuring out how small we can shrink that yet on the live network. In our test environments, we often have it at 3 seconds. But yeah, we're working on something where you pass off a message to gateway and it will deliver it to the right place. And this is part of actually Jay can talk about that system more. It's part of an approach to make it so that the network is less dependent upon global connectivity.
Yeah, I mean, one of the primary challenges with clients, especially, I mean, I think, broadly speaking, most clients that will be on the network in the foreseeable future are going to be on mobile phones, and obviously there's all the platform-specific constraints and challenges involved with that any major app will see. But it's also just like an incredible resource limitation versus say a client that you'd be able to run on your machine and sort of build directly and run with Go. And so, as part of that, we've been outlined the system for how clients work, and really much of it is sort of as simple and dumb as possible, in order to basically ensure its reliability and sort of ease of understanding and testing. And then moving forward, of course, when you approach these limitations of the mobile app, you've got to start getting more clever with how everything is meant to run, and start to iterate and really and even very simple things like deciding which gateway you're going to talk to, can become a really important decision in terms of, say somebody's got a old phone, lives, in a place with not excellent internet. You want to not have to be talking to every single person all the time, because it just doesn't work. That's like in a global, worldwide internet, that just is never going to work for everyone. And so part of our first steps here, I guess, in improving how client works is sort of intelligently, sort of building. I don't know if relationship is the right word, but really determining which gateways it can interact most quickly and with the least problems with, and sort of drawing from a pool of those to speak to. And then those gateways, you can go on, and as you were saying, sort of forward those messages on. In other words, it puts the onus on the network a little bit more than it does on the individuals using it, which is, overall kind of an approach we try to move towards where possible. So that that's one of our first steps, and that will be coming up quite soon.
All right, thank you.
Ben, would you like me to read out some more messages?
Yeah, why not?
Okay, we've got a message, test. We've got another message, welcome from Belarus. Someone's gone, hello world. Got, this is so cool, XX rocks. We got hello. There's a message, give me please XX. We've got hello from Australia. I believe XX project will be a game changer. We've got hello. We've got Much Love from Australia. We've got xxDK Celebration. We've got Hi to All. There's Thanks from Spain. There's Let It Be. There's Hello from Ukraine. There's Let's Do All More Faster. And we've got Hello XX Community. Greetings from Chile. Those are the messages that have been sent since the last time that they've been read out.
Okay, so we had a question on the chat that I'm going to read. Where was it? Should have found it before I said that. What is the ratio for smooth and fast delivery of messages to high number of node operators? I'm going to talk about this in the long term. Right now, there are some clunky algorithms in the client, which over the next few months we will improve. Once that happens, there is no ratio. As the number of node operators improves, the smoothness and ease of use of the network increases. This is one of the kind of really great things about this system. The mixing part isn't a blockchain, it's a mixed network, and it works in different properties where, because when you're mixing, that message isn't going to the whole network, it's going through the same fixed size. Right now it's 3, I think soon we'll get it to 5, if not higher. But the because of this property of that it's batched within a small group, you don't have this issue where as more nodes join, it gets harder and harder to run. There is a max scale because of the gossip and a few other things, but we're not particularly close to hitting that yet. So somewhere maybe around 5 to 10,000 message nodes, you'll start to see some bottlenecks. But even then, eventually we can deal with those issues. So the real answer is, it just gets better. And this is part one of the reasons why we think that not only is this, the XX network and the Elixir CMIX protocols so valuable. It's also why they're good for a blockchain, because their economics are so different that they can really help drive the blockchain and how they interact. So yeah, that's my answer for that. There's a question here: are we allowed to tinker/attack the network, or should we wait to do so yet? From Mike Jans. This is always a difficult question. Certainly tinker. If you attack, you find something, we obviously prefer that you notify the team first. Downtime just never looks good, but if we've been a little bit too arrogant, it might be good to put us in our place. The one thing we can say is that, if someone does something that causes prolonged issues for the network, a node operator does, it might get kicked out just because that's what happens if the network isn't working. So, keep what you do reasonable and everything, and I think the answer is yes.
We're always looking for an excuse to work the weekends.
Exactly. Yeah, if you keep it within our 9 to 5, we generally appreciate it.
Yeah, exactly.
Can I ask a question?
Sure.
Hi there. Mine's not quite so technical, but I'm sort of trying to work on sort of the sales pitch for when I describe the network to people who've never heard about it. And I keep falling short because it turns out I don't actually know that much about it. And I got slightly caught out the other day talking to an accountant who actually turned out to know quite a lot about blockchains, and she raised quite a lot of questions I wasn't really able to answer. So I wanted to sort of ask, how to develop sort of the sales pitch that promotes the network to people who've not heard about it before. So I was wondering whether you're able to compare it to the sort of the nearest contenders in terms of speed, in terms of privacy, and in terms of quantum security, maybe, that I could sort of use as a means of comparison to sort of put it into some sort of context when I describe it to people. For instance, let's say, what would be the closest contender in terms of transaction speed, and how do we how do we compete on that level?
So there's a few different questions in here. There's on the blockchain side and there's the mixing side. On the mixing side, there really is no comparison. The closest networks are things like Tor, but even those are not good analogs. The XX networks adversarial model, the things meant to protect against, are very different and are designed to be a little more extreme. On the blockchain side, I think that someone from the Praxis team could probably take that better than I could. I don't know if
Sorry,
Will is
yeah,
available.
I'm managing the streaming, so I gotta unmute multiple things here. I'm actually looking for a slide that I believe we had in one of our webinars a long time ago, that does a good job of explaining how the consensus and blockchain portion of the project compares to a lot of the more popular projects out there. And I'm just gonna bring that up real quick.
That's interesting because in particular, this conversation I had with this one accountant, for example, when I was describing the teams of 3 and then the greater sort of permissioning over and above that, her response was that if transactions were being settled in teams of 3, it wasn't a blockchain. And I was kind of he said, and if they're only being settled in teams of 3, is that a security? You know, how can that be? You know, so you had a conversation between 2 people who didn't know enough about this to really, you know, to have a proper conclusion.
No, so, it's a good question. So the first thing I would say is the blockchain portion of the project does not settle in teams of 3. The teams of 3 is specifically for the communications module of the project. So it's the protocol that's implementing CMIX. The consensus protocol itself, to give like a 30-second lesson on it, one of the primary mechanisms we use to speed up our consensus is something called like random sample endorsement, where we take a subset of the network and randomly chosen for each block, and that subset is responsible for doing a lot of the heavy lifting of computing that block, or validating that block, I should say, where they're receiving the full transaction, which includes the signature and everything. They're validating it and they're endorsing the block. That endorsement subset is much larger than 3. It's I want to say it's in the hundreds of nodes. So I think that particular question was just a mix-up between the 2 different protocols.
Yeah.
So ours does fall within like the standard kind of consensus safety assumptions. So it is a blockchain. There is a consensus mechanism. It's assuming 33 or 1/3 plus 1 of the network. Sorry, 2/3 plus 1 of the network are honest at any given point. And then generally we're using at least 200 members of the network to process each individual block. And then I'm going to present this screen right now.
Yeah,
I have a question.
Sure.
I have a question. Is there thought about to make it very easy to copy paste my whole address book of my friends to get over to the messenger?
Yes. We're about to move to a messenger segment, and I think we can talk about plans for things like that. Kate is here to help us with that. Why don't we finish answering the questions about the blockchain, and then we'll get to that if you don't mind.
Okay.
Oh, but the community won't be able to see it because it just says I'm presenting my screen.
All right.
I think
give me a moment. I'm gonna share it with I'm gonna share it with you, Ben, and then you can save the screen.
Yeah.
So unfortunately, there is kind of no short answer to how all these blockchains and the consensus protocols compare. A lot of them fall under what's known as like a BFT approach that's largely based off of PBFT, which was the first kind of practical, that's why it's called PBFT, it's practical Byzantine fault tolerance consensus. A lot of these consensus protocols were based off of that. That would include Cosmos here, that would include Libra. And I think most stake-based platforms follow the same consensus approach. And then you have like proof of work protocols like Bitcoin and Ethereum. They take a bit of a different approach. And then the most recent advancement, the most recent large departure from that approach, I would say would be Avalanche, which is using like a DAG-based approach. All of them have kind of pros and cons. As you can see, in proof of work, I think the cons are pretty obvious. We've all experienced them for quite a while. Latencies are massive. Throughputs are quite slow. And the finality in the case of a lot of Byzantine or malicious behavior in the network increases radically. And that's because you have different portions of your node network competing for a different branch or a different fork, I should say, of the chain. So this is how you would, this up here is the proof of work kind of environment. Cosmos and Libra, as I said, are, and I think Algorand as well, are in the kind of PBFT inspired approach, obviously based on stake. And the benefits to this approach are that you get much faster latencies. So you're generally getting under 60-second latencies. Usually it should be a lot faster. But the downside is generally it doesn't scale well to a lot of nodes. So where Bitcoin and Ethereum, you have, you know, tens of thousands of miners out there. These PBFT approaches are limited generally to less than 100 nodes, sometimes a lot less than that. And it's also a known membership type of system where you have to actually know who, for every given block, you actually have to know who all the valid nodes in the network are. Whereas in Bitcoin and Ethereum, you may not know who all the other nodes in the network are because you're just waiting to see someone win the mining contest and propose the block.
Yeah.
And then DAGs are a really, really interesting approach that has a lot of scaling properties, but their Byzantine assumptions and their performance in the face of Byzantine adversaries is not clear. What we've seen so far, or what we've seen in the math, shows that if you do end up having a large percentage of malicious nodes in the network can slow down to basically a halt. I don't think it threatens the safety of the network, but I think it starts impacting the liveness of the network quite dramatically. So we took kind of the PBFT inspired approach because it's fast. It allows us to do kind of some of the unique economic staking opportunities, and also, you know, it fits well with the integration with CMIX. Obviously, one of the downsides that I mentioned to that approach is that it doesn't scale well at all, at least traditionally. I don't remember exactly how many nodes Cosmos has. If someone wants to look it up, that'd be great. But I'm almost positive it's less than 500, and basically every other system like this falls in line with that. What we've done in the network using that kind of random sample endorsing that I mentioned previously is we've increased that scaling capability to be linear with the number of nodes. So we demonstrated in our webinar that we were able to push through 3,000 plus transactions a second on 1,000 nodes. And I don't have the graphs here, but we did show them in that webinar if you want to look at them. It shows that the network should continue scaling well past 1,000 nodes. So that's kind of like the primary advantage here. And then also, none of these consensus algorithms are quantum secure, obviously. And introducing quantum secure signatures to an existing consensus mechanism generally makes that consensus mechanism like an order of magnitude slower, because the transactions are just so much larger and slower to validate. So another,
So you could somebody.
Go ahead.
So somebody couldn't argue, therefore, that you could just alter one of the existing systems to become yeah. Because that's, I mean, that's an argument I've had. It's like, why can no one just update their protocol to reach the same goal?
Yeah, they absolutely can. It's just it's going to bring an already slow network kind of to a crawl. It'll slow it down a lot, and also it introduces a lot of usability considerations that a lot of the networks haven't been built around. So, for example, what I would consider and what most of us consider the most secure quantum secure algorithms or signatures are based on hashes. And the problem with using these signatures, or one of the downsides to using one of these signatures, is they can only be used once per public key. So when you have a public key, generally you can sign an infinite number of messages with that public key, with the private key that corresponds to that public key. With these hash-based signatures, once you use the private key for a public key, you can never use it again, because using the act of signing the message gives away certain information that could be used to forge signatures if you were to reuse it. So that it's a very important consideration that needs to be taken into account when you're developing the blockchain, when you're developing the wallets, when you're developing every layer of the platform. So yeah, number one, it's going to slow down your network a lot. Number two, it's going to introduce a lot of usability issues if you haven't built all of the applications that use your chain around this limitation. And we've also kind of developed some unique quantum secure group endorsements that help address some of these performance issues. So yeah, they could in theory do it, but these numbers are going to get even smaller.
Right. And
just point out, like for example, other consensus usually use threshold signatures like VLS, and with quantum secure signatures you can't really use that. So that removes the linear aspect of the consensus. That's why with our endorser sampling we can get a constant proof of finality, and that's how we can reach the linear aspect as well without threshold signatures.
Wow.
So I don't want to cut this conversation short, but I'm going to cut this conversation short because we have a final topic that I want to discuss that I think a lot of people are interested in, which is the XX Messenger. So we have Kate with us. Kate, for those of you who don't know her, she runs the team which is building the XX Messenger, as well as that builds the websites and a few other things that all of you have seen. She is quite capable, and she really does a great job. And I think that we're going to talk a little bit about the philosophy behind the XX Messenger, how we're building it, and a few other things. So I'm going to hand it over to Kate.
Hey Ben, can you stop sharing screen?
Thank you. I would not have remembered to do that.
So let's go. I want to start with a question that was already asked. And to answer that question, I want to give a little bit of a fundamental on how user discovery is going to work on the Messenger. And for those of you who've played with the xxDK, you might already know a little bit of this, but I'll give a high level. So basically the way that it's configured is that users can create an account without having any type of public profile, that's what we call it in the Messenger, without uploading any personal information to user discovery. which is what users can search on the network to find other users. So there's a path on the messenger where you can be entirely private. So to that idea of uploading contacts from your contact book, if all of your contacts chose that path, you're not going to get a lot of hits if you search them. As far as users who do choose to create a public profile, put information on user discovery, you can actually put 3 pieces of information. In this, we might expand later, but for now, you can put your username, email, and phone number. So that's pretty nice in that if you have a contact by email or you have a contact by phone, you can actually search for both of those rather than being just limited to phone number like some of the SMS-based ones are, like Signal or a couple of others. But it also means you might get multiple results depending on who you're using, because the messenger is very easily configured to have a couple accounts if that's what you're trying to do, or if you have you only want to use email, you only want to use phone number for different privacy reasons. So this is to say, this is on the roadmap to search your contacts, but there are a couple edge cases that we have that other messengers don't currently have. Like if you use just SMS, it's fairly simple to just check, okay, is this phone number in the database? The check on our side is a little bit more complex right now. So even if you say, okay, I have 100 contacts, I'm just going to run all these phone numbers. Right now, that's a fair amount of usage for your phone. And what actually happens, you say, okay, I'm going to run all these phone numbers and all these emails. Or this contact has 2 phone numbers, I'm going to run both phone numbers. So what we're trying to do right now is get this functionality to a place where it's really usable, and figure out the issues of sort of, can we run in the background? Can the user accept? And then when they go on Wi-Fi, we're going to run this overnight, that kind of thing. So it's not, you're actively trying to use the app and there's massive background processing. We're also, in the final stages of refining the xxDK. So it's a little bit slower right now in testing than it will be for the actual public release. And that will also help alleviate some of this.
Yeah, I mean, this touches on kind of the core theme of hours of conversation inside the team about the trade-offs between privacy and usability. And there's almost always a trade-off, and you've got to find the appropriate balance.
Yeah, we've gone back and forth on that question a lot. What we've tried to do is have there's always a path for usability. So if you're a user in the privacy community, there are a lot of users who are really used to sort of managing their own settings, their own apps. They're fairly technical. So if they got to a phone, an app, and it said, okay, here are 10 options, how do you want to manage yourself? A lot of people already in the privacy community wouldn't be shaken. But we want the XX Messenger to be accessible to people outside of just the privacy community, because it is an issue affecting everyone. And a lot of people who are a little less technical understand, they're starting to understand, okay, I'm getting all these creepy ads on Facebook and Instagram. This is something I might want, but they don't necessarily have that capability to say, okay, I'm presented with all these options. Now I just have to manage all my settings for myself. So what we've tried to do in designing the app is to say, if you're a really privacy-oriented person, those options are there for you, and you can manage it. You do have the freedom to go through and control all of your own settings. But if you're less well-versed, you don't really know, or you aren't as well-informed on sort of what the consequences of those might be, that there's also a default path that you can just sort of opt into, and that path is slightly, more usability, slightly less privacy versus the 100% privacy and a couple of sacrifices in usability. But that being said, we have what's informing that is we do have a baseline of privacy for our app, which is the core claim. It is decentralized, which we don't talk about as much. We talk a little bit more about, or we have talked a little bit more about metadata protection and sort of the privacy claims of CMIX, but the decentralization is also a huge part of it. And with those two things together, there's sort of a clear line in the sand. We can't go below that threshold, but above that threshold, we have a slightly more usable path, and then the option to configure your own settings.
Sorry, maybe I have to ask my question again. Maybe I didn't say it right. Now, it was more, is there some kind of invite to my friends to using this messenger? So, for example, I have now WhatsApp. So I send via WhatsApp, hey guys, I'm using XX Messenger. Please come over and join this. So that I can immediately invite 50 people, and those 50 people can invite 50 people. So it is like
kind of a viral effect.
Yeah.
Yes. We will. It's not going to be implemented in this testing version, just because this testing version is limited. But for the public release, we are looking at doing that. And because there is QR support, it's kind of easy. If you can search for people if that's easier for you. But for friends, for me personally, everyone I've added so far, I just give them my QR code because it's a lot easier. So what we want to do is have some sort of invite. Hey, download the XX Messenger, and also here's my code. You can add me. So then you're sort of both things that you can get started messaging.
Yeah, because then it's not too complicated in the beginning, even to start with the messenger. So that will be more like a oil spot.
Yeah, we try. That's part of the reason we added QR codes in this release. Was in the alpha release, it still had some of the search functionality, but because it was username based, a lot of people. I personally have so many usernames. So people would say, oh, I know my friend, they're definitely this. And then when they get to the username, they couldn't find the person. So having a QR makes it a lot easier if you're just trying to add friends. You can knock it out, throw it on your public, your story, put it on Discord, whatever. And you can get, it's easy. This is 100% me. Just scan this code and then you're in. Because we're trying to make that transition easier for a lot of people. Instead of, you have to jump through these 6 hoops and then you can get started.
Okay. Well, thanks for the answer.
No worries.
I want to talk a little bit about that. This is actually something that I've not discussed in detail with Kate. This is something that I think we have a long road on. There are some designs for mechanisms where you actually send this request over the XX network. It forwards it to a person. And then that person is able to take it, use that invite to start the XX Messenger with you already paired. And so we want to make this as streamlined as possible. There's obviously limited development time and effort, but it's pretty important to us.
Will we ultimately be limited to what can be sent in terms of a message? I mean, would images be something that we would be able to process through the network, or is that not going to be possible?
We're looking into different ways to support images. Small images, compressed ones, you could send right now with no problem. And in fact, there is. Did we end up sending compressed images for the preview feature?
Yeah, we're using that right now for URL previews.
Small images, yes, and we've got plans for, in the long term, we've got a design for what we call large payload, which is a mechanism for which takes different privacy trade-offs to allow for a higher bandwidth link. We've got some ideas for some, first versions of that we could deploy quickly that will have more privacy trade-offs, but would allow fast usage within the messenger of file sending. So,
is that something that would ultimately tie in with the paid and unpaid transactions, whereby, say, a bigger lump of data would potentially push you over into the threshold of a paid message, or is that sort of the idea?
I mean, that's certainly one potential. When talking about privacy systems, we normally think in a binary of as private and not private. But in fact, within the scope of private systems, there's many other types of privacy and interactions. And one of these is how you deliver. So CMIX is a system that delivers a broadcast or delivers to a specific party. But you have other systems which make very different trade-offs, which could kind of just deliver anywhere and would be a lot more higher bandwidth. But because you kind of deliver to a random place, no one knows how to pick it up. So that pairs very well with a system like CMIX. So I think that the question isn't more so, will you be able to do this eventually? Will you be able to do voice? Will you be able to do super low latency video? I think yes. I think in the long term, all of those things will be possible. I think that really the more important question is, how can we deliver, simplified versions of these things quicker so that we can really grow the network while those larger things are being developed?
Right.
That's important to us. Not just XX Messenger, but the network as a whole is a little bit of this dance of, getting to this ultimate privacy, a world where we've got privacy, and finding the right increments to get there. You've got to evolve the network so each and every step adds more capability and brings in more users and gets you to that point. If you say, we need to be at the height tomorrow, well, you run out of money, we'll never finish.
I can see that. Yeah.
So, do people have questions?
I think mine were more sort of node running type of questions that I had. I had more questions to do with staking, this kind of thing.
We don't have much that we can say about staking yet. I think we're going to have those answers in the next few weeks. So we're happy to take the questions, but I think that we're more likely than not just to say, please hold on.
Sure. I did have sort of conceptual question I thought was quite interesting. It seemed to me like a bit of a paradox if the network's going to start taking a staking approach, whereas the true staking networks provide the transacting power to the highest stake nodes in the network. And I thought that was quite an interesting thing, because that sort of undermines the randomness of nodes. So I figured you'd have an interesting approach that would avoid that problem.
Well, the network is really two protocols in parallel. So I think that the simple answer to that is, the blockchain might be based upon your stake, and then the mixed network will be far more egalitarian. So that's the simple answer. But I don't know that we've fully answered that question. We've got a lot of different ones that we're working on. And Will's is much involved in this as I am, but
I could say,
more.
Yeah, one thing about it. While we do take a staking approach for kind of node membership, we do not follow a staking approach for block production, which is to say, having more stake in the network does not give you a larger probability of producing a block.
Right.
So yeah, like in a lot of these stake-based platforms, the more stake you have, the more blocks you're generally chosen to be the producer for, the more node rewards you get. In ours, we use the staking approach to basically select the membership set. And then within that membership set, all nodes basically have the same amount of power. So they're all equally probabilistically chosen to produce blocks, process transactions, etc.
Sure. That makes sense. Yeah. That sort of leads me back to the question that that seemed to be around a lot in the previous few months regarding the performance of nodes and whether there was any benefit in sort of tiering or managing how the performance of nodes affects other nodes, and whether there was any potential to I don't know, tier. I discussed the idea of tiering. Maybe I was always interested in that idea, whereby a slow node couldn't ever be exposed to a really fast node to hinder its hinder the speed of transactions. This is all part of the permissioning, big picture of permissioning, I gather.
Yeah, and that's largely a CMIX specific question, or the communications protocol question, because the speed in consensus, or a node being like somewhat slower than the other nodes, generally won't be caught or managed in the same way as it is in CMIX. In CMIX, if you have one node in a team that basically doesn't do its job, like it's too slow, it doesn't get the data in time, that round fails, right? In consensus, it's kind of, as I was saying before, there's this BFT assumption that, you know, at least 2/3 of the network is running and online. And as long as you have 2/3 of that network online, unless the node chosen is the block producer, it doesn't really matter if, you know, they time out or they're slow. What might end up happening is, in the aggregate, given like performance reports to the public may stop staking on that node because, you know, it's less performant, or it's, you know, not doing its job when it becomes a block producer. So you're getting a lot of blocks that are skipped. So like they're very different kind of paradigms between the communications protocol and the blockchain protocol, whereas it's critical, or a lot more critical in the communications protocol, to make sure that the nodes are performing. In consensus, it's got a lot more robustness in the aggregate to nodes that aren't quite keeping up, though the community might kind of filter you out over time.
Right. I think that's all my questions.
Good questions. Thank you.
Thank you.
So it's coming to the end of the event. Sydney, do you want to read off any new messages that came through one last time?
Sure. We have hello privacy. We have hello XX community. We have hello decentralization. We have salutations from Romania. There's greetings from the Netherlands. There's more coins. There's hello world. I believe XX will change the future. Got more coins. We've got hello world. There's easy game. There's hello world. There's very exciting times. Love the work the XX team has done. Keep it coming. Bravo. And just greetings from Chile. Looking forward to trying Vote XX here. Ooh, my alarm clock is going off. There's Hello World. There's XX Network. There's Hello Gamers. There's Hello World. There's the XX team is the best. There's thank you for your work, XX team. And there's great.
So I think we're gonna turn off the game because I think the time period is over. We have a few node operators that came in the last minute. So if anyone has any burning questions that we can answer quickly, we can do that. And then my guess is that David would like to finish us off. Is what it looks like.
René or Bulldog? Just saw René is coming in.
Yeah, I got kicked out. I'm back in now.
All right, Bulldog.
I was going to ask, are we still in BetaNet?
I think we're technically in technical mainnet because the xxDK is launched.
Sure.
I think that's the technical answer.
Sure. But the messages can be assumed to be sort of in BetaNet because it's only community based. These aren't public messages at this stage.
I mean, the APIs are open, so in theory, anyone could grab the xxDK and start sending. And the XX messenger is we're gonna get live soon. So, and the other thing is that I'm not saying that. Don't take what we say to say that there's no flaws remaining in the code, but we fixed all known security flaws in the system as of now. It's in this state where it's really ready for people to, begin the process of using it. Obviously, we still need to do audits, and you can never make too strong promises about any security, but at least I'm pretty happy with where we've gotten to.
Great.
David, do you want to finish this off? It sounds like we're coming close to the end.
Sure, Ben. Thanks. Yeah, I've been listening in and watching it. This has been really great experience to see members of the community we hear about, but we don't really see them, and to have everyone come together and have some of these various discussions that have, been, I think, extremely interesting, and I think a lot of the key issues have been touched on one way or another, and it's I mean, this is very exciting to see the whole project taking life in this way with such a level of maturity and interaction with the community. And yeah, so it's been a thrill for me sitting in and watching. And I just want to thank everyone from the community members, people that have appeared here specifically, and all the people that sent in the kind messages, and of course the whole XX team. That's we're it's a lot of really fabulous stuff goes on, and maybe if you're listening in, you start to get the feeling there's a lot of discussions about all kinds of future aspects, and a lot of alternatives are considered and comparisons with other systems and so on. And generally that sort of thing is not exposed. This is one, that professor I was sitting in the hot tub with, just to bring it back to my opening remark, told me, because I was like a new graduate student actually at Berkeley in the computer science department, with Bill Joy and Eric Schmidt, and those sort of people were my colleagues, and Sylvia Macaulay and Shafi Goldwasser as well, and the Vaziranis. I mean, we were all in this cohort, I think. But what Bob Fabry, who was also, by the way, head of the BSD project, told me was very early on that when you write an academic paper, you don't get to say all the millions of different things you tried and thought about and so on. You only get to talk about the one specific proposal that you've digested from that. And it's the same with a project like this, but there's a lot more that goes on behind the scenes, and I think you're getting a little bit of a sense of that. But I think the overall message is extremely important, and as I think coming through relatively clearly, which is that as far as we know, this project is solving a very fundamental problem that the world has recognized, the metadata problem, and more or less uniquely. And it additionally compares very, very favorably to the currently popular blockchain projects in terms of its ability to really be robust and to scale, not to mention the quantum resistance, which is very hard to build in after the fact. So, and then I think that all the thoughtful consideration of different privacy and performance and robustness issues shows that the solution we have can really make it to mainstream. I mean, that wasn't, let's say, a given a priori. It might have been that mixing just can't go mainstream for various fundamental reasons. We didn't know for sure when we embarked on this, but at this level of implementation and maturity and discussion and exploration of alternatives, it's clear that to us that there's no real roadblock, and we can move forward to a global system, and the world really needs this. So yeah, it's just been super great to be a part of this conversation. I want to thank everybody for all their work and contributions and support and interesting ideas and so forth. So again, congratulations to the whole team and the community and the world, and we'll see you next time.
Thanks everyone. Thank you.
Thank you, David.
Thank you, everybody.
Thank you all.
Thank you.
Have a good one, everybody.
Bye bye.
Thanks, guys.
Bye-bye.
Thank you, everyone. Bye.